Okay, welcome to Maths with El Profe, doing some elementary number theory using the textbook by James K. Strayer. And I'm going to talk about some congruences, which are also known as modular arithmetic. Alright, so we have our definition. It says that if a, b, and m are integers, where m is positive, then a is said to be congruent to b modulo m, and it's denoted as a congruent to b modulo m. Right? These three lines indicates a congruence, and that's going to be true if m divides a minus b. Okay, so this little piece is going to be important for the mathematics, but we're going to think about it in a different way that will make it easier. So we say if a is congruent to b modulo m, right, then m is said to be the modulus for the congruence. And if a is not congruent to b modulo m, right, then we say a is not congruent to b modulo m. And a is said to be incongruent to b modulo m. Okay? Another way to think about these congruences is to consider a equivalent to b mod m to represent having a items grouped into groups of m with b items left over, right? So in other words, right, if I had this many items, right, and I said, well, let's group these items into groups of 3, right? Well, the implication here would be that 7 would be congruent to 1 modulo 3. Right, that if I had 7 items and I put them into groups of 3, I would have 1 left over. Okay. Now, an equivalence class refers to a set of integers that would have the same remainder when divided by m and are denoted with the notation with the brackets and the x. Okay. Now, I do have a footnote here, and it should be noted that this is an area of mathematics where similar notation represents different concepts in different places, right? So this notation here you might see differently to represent the same idea. As well, this notation could refer to the greatest integer function if we were working in a different area of mathematics. And that greatest integer function sometimes called the step function. But it is important to note that in mathematics there are quite a few areas where the notation in trying to keep things simple is duplicated across different items, and it's important to define. Okay, so let's look at some examples before we go on and do some practice problems. So example 1. Right, since 4 divides 25 minus 1, right? 25 minus 1 is 24. 4 divides 24. We have that 25 is equivalent to 1 mod 4. So in other words, when 25 is divided by 4, the remainder is 1. Right? That's our simplest setup. Okay? Now, since 6 divides 4 minus 10, right? 4 minus 10 is negative 6. 6 divides negative 6. We have that 4 is equivalent to 10 mod 6. Right? So in other words, when 4 is divided by 6, the remainder is the same as when 10 is divided by 6, right? If I had 4 items and I said get them in groups of 6, how many do I have left over? You've got 4 left over. And it would be the same as if I had 10 items. I said, hey, 10 items, get them in groups of 6, how many are left over? Well, once again, 4 left over, right? So that's where we have this equivalence, that we're going to have the same remainder when grouping by 6. Okay? Now, this next one is a bit tougher for people to understand when they're first experiencing modular arithmetic and congruences. And we'll say that since 7 divides 10 minus negative 4, right? That 10 minus negative 4 is 14. 7 clearly divides 14. Then we have 10 is equivalent to negative 4 mod 7, right? That 10 is equivalent to negative 4 mod 7. So in this case, it may be easier to consider that when you're grouping by 7s, if I'm going to say, hey, I'm going to take things in groups of 7, well, 10 items will have a remainder of 3, right? Now, when might I have -4 items? Well, you could think of a ledger, like a money ledger or anything else that you're keeping track of inventory, right? So if I have -4 items, right, well, that will have a remainder of 3 once I add 7 items to that negative ledger, right? So if I'm putting things in groups of 7 and I'm short 4, as soon as I get that next group of 7, now I'm going to have 3 left over that I can't put into a group of 7. And that's the idea. Okay? And finally, we have the next example that talks about the equivalence classes or the residue classes of integers under congruence modulo and whatever modulo you have. In this case, we'll say 4. Right, and those equivalence classes will be, in case of 4, 0, 1, 2, and 3. Right? Then when I'm taking things in groups of 4, I'm either going to have nothing left over, in which case 4 divides the number. I could have 1 left over, or I could have 2 left over, or I could have 3 left over. And in general, if I'm working with mod M, the equivalence classes in general are 0, 1, ... all the way to m-1. Okay? And of course, in these footnotes is where I talk about the issues about the notation we did earlier, and then also this notation with the brackets, which is what we will use consistently, could also be written with the bars. So 0 bar, 1 bar, 2 bar, 3 bar, and sometimes that's what you might see when you're working with this concept in abstract algebra. Okay? So there we have an introduction to congruences and how to think about them. Thanks for taking the time and doing the work with Profe Lo.